Okay, we had, and I thought I had this on camera, but it's fairly straightforward. This set of points is characterized by the fact that if you think of this as x and y coordinates, your y coordinate is 5 times your x coordinate. Well, that means that these points are exactly the points that lie on the line y equals 5x, which is a line through the origin. And then we comment that if you take any point on this line, you characterize that as the vector, as we've done, from the origin to that point. Multiply that by any number, you're still on the line. Okay, so that is equivalent to saying that you multiply by any real number, you get a vector that's still in the space. Okay? Or if I add two of these, you know, if I did this one and then added this one, well, it would be this, and then we go back here and we have this one. So add any two vectors from the origin to a point on the line, it's still on the line. Okay? Now over here you have what? Y equals 5 times 1 less than this number, right? So y is 5 times quantity x minus 1. Well, the set of points that satisfy this in R2 lie on a line here with a y-intercept of -5, the same slope, 5, as this one. But now if we do a vector from the origin out to this point, that's identified with the ordered pair, okay? If I double that vector, let's say, well, I'm no longer on the line, so I'm no longer in the space of ordered pairs of this nature, with this characteristic. So there's a geometric reason why doubling this gave me something that didn't satisfy this condition. And clearly adding two of these, if I added this one to this one, I would get this. And clearly that's not on the line either. And you can show that algebraically or you could show that geometrically. Now if you're in a higher dimensional space where you can't show it actually geometrically, then you got to go with the algebra. But you can still understand in terms of this picture what's going on. And what it comes down to is if you have a set of points in R2, in you know, two-dimensional real space, or 3, if all those points lie on the same line through the origin, then they form a vector space, which will be called a subspace of R2 or R3. In R3, you could also have a plane through the origin. And if you take two vectors on the plane, you know, vector out here on the plane, a vector out here on the plane, and add multiples of them, you're still going to be in the plane, if the plane is through the origin. If the plane's not through the origin, it's not going to be the case anymore.